Hi, good afternoon. Well, this is a big room, big audience. So I want to spend the next few, 30 minutes or so, talking about event correlation. And there are two reasons. It's a topic that I find very interesting, and I think it's good to somehow demystify when we talk about correlation or event correlation. What is it exactly that we're talking about? And perhaps some of the inner workings of how event correlation sometimes work will actually surprise you, and that's why it might keep you awake. But there's another reason, more fundamental, by which I wanted to talk about event correlation, and I'll explain that later. So ultimately, the reason why we need or we want event correlation is because we have this big pain point about the operational noise, right? You have all these many alerts, events coming from the network that the network engineers or NOC engineers have to deal with, and what we need is some mechanism to bring that down into some more relevant signals, right? Some incidents of sorts that might aggregate those events that have to do with each other in some way, right? Perhaps some are symptoms, maybe one of them is the root cause, but that's what we really would like to, conceptually. But how to do that is now the question, and how to do that effectively, right? Correlation sometimes looks like a very mysterious term, and people talk about the correlation engine, like some magic box. But correlation, if you ask people from the data world, they will just tell you, well, that's a join of two tables. You just connect two tables with something that they have in common, right? That's correlation. That's, in essence, what correlation is. It's finding a relationship between two data points, right, and connecting them together. Now, when we talk about network event correlation, what we are looking for is what is the relationship between events that are happening in the network, right? In this example, let's say we have 3 events, right, that happened. Are they related in some way, right? Or are they independent? Perhaps there are 3 different failures that happen somewhere in different places. That's fine. But it could well be that 2 of them are related, are connected, and maybe one of them is independent. It happens somewhere else. Or maybe it's the other way around, or maybe all 3 belong to a common incident, even though they happen in different places in the network, and that's very common. So that's what we need to answer, hopefully, with high quality, right? Because if we produce correlation of events that are not really connected with each other, actually the system is going to be misleading you, or misleading your network engineers, which means they now have double work to figure out what is real and what is not, which is kind of a weird issue. How has event correlation been done historically? There are several techniques, right, that your vendors have been using, right? The simplistic method is time-based correlation, like temporal correlation, which basically means you get 2 events, let's say, right? You have definitely some rules to parse the event, to extract different fields and whatnot, right? And then you have some structure representation of that event. But essentially what's going to happen is that there is some time check. And if the 2 events happen within a specific time window, they are considered correlated, which of course, is not necessarily true, because there are a lot of things that are happening at the same time in a network, especially in a large network, that have nothing to do with each other. So correlating based on time only, it's not adequate, right? It will produce bad quality correlations, and it will mislead NOC engineers. So because of that, then, we came with another method, which has been, widely used across many years and products and so on, which is the method based on rules, right? So again, we have these 2 events that are coming in, we parse them, we put them some structure, and then we have a rule engine, right? A rule engine that is fed by a bunch of rules that someone has to create and has to maintain. Right? And those rules are if this, then that rules, right? If these 2 events happens and they match in this field and this other field and this other field, then they are correlated. So based on the rules and possibly as well on the time, the 2 events are connected and are happily correlated together. And this has been going on for many years, and it sort of works, but it depends on the quality of the rules that you create and the effort that you put to maintain those rules. And some people end up with hundreds, if not thousands, of rules, with a lot of difficulty to maintain them, to know what each rule is for, and obviously it becomes very challenging. And there's a fundamental issue with this, right? Is that you only create rules for the things that usually are more frequent, right? Because that's it pays the effort to create a rule for that, right? Or maybe for the things that you find, maybe they are not that frequent, but they are important, so then you create a rule for that. But there's always going to be that case where there is this new syslog message or the new event that comes that no one has seen before, for which you didn't have a rule, and you missed that, and you were not able to correlate it, and that didn't lead to the proper root cause analysis, etc. And the problem was, hey, we didn't have a rule for that. Well, how can we solve that, right? That's one of the questions that we would like to answer. Then over the past few years, some vendors came up with, hey, let's use machine learning, right? That sounds, an opportunity to use machine learning. And they came up with this idea of similarity, right? Which, by the way, has nothing to do with machine learning itself, right? But, it's always good to put the ML thing around, and it makes things more sexy. But let's say you get two events, right? Again, you have still probably some rules to parse, to extract fields and whatnot. And then you have the two events in a more structured way with certain attributes, certain fields, the type of event, the device name that the event came from, perhaps the interface name if it's associated to an interface, and so on. Now, what you do basically is you represent those events in some form of vector, which is based on the labels, the attributes that describe that event, right, the metadata. And then you find some way to compute the similarity. And there's different types of similarity, cosine similarity or others, but that's just basically a mathematical, formula that will give a number, whether the two events are similar or not. And it's sort of intuitive, right? Well, if the two events are similar, then perhaps they are correlated, right? And that's the assumption here. But the problem with this is that, correlation, when we want to find correlation, we want to find whether these two events are really related with each other. And the fact that two events are similar really has nothing to do whether the two events are correlated. It just says that the two events are similar, right? But that doesn't mean that they are connected, right? A network is a much more complex and very horizontally distributed system where things might happen in different places of the network. The fact that two events are similar, again, is just that they are similar, right? Why do we use, or some use similarity? Because it's very easy to implement. It's very cheap to implement. And then you can get something that looks like a correlation, but actually the degree, or efficacy or the quality of that correlation, it's, in my opinion, questionable, right? Because again, many events happen on a network that are connected, but there's no similarity whatsoever at the event level, right? So we need to be very careful when we use similarity of events as a proxy to determine event correlation, because that might not be the case. Then also, interestingly, over the past few years, also others started to use network graphs as a way to derive correlation of events. Somehow, how close the entities associated to the events became the metric to determine that the two events are somehow connected. And it's actually a very good approach. Still, you might need some rules or some mechanisms to parse the events and extract the proper fields. But then once you do that, and once you find the entities in your network graph, right, in the digital map or whatever term you prefer, then you can decide if they are sufficiently close. That means there's a strong semantic connection, right, at the network level between these two events. And that's actually a very quite effective method, right, to derive correlation between the two events. But still, you have to create all those rules to do the mapping between the incoming events, especially if they are unstructured, like syslog messages, to your network graph, right? But this is actually a quite good mechanism to do correlation, by the way. I like it a lot, right? But as an industry, we're entering into a new era. And I think we need to evaluate whether we need some methods in this new era. And what is this new era about, right? I'm sure you've heard about the idea of the autonomous network, right? I mean, it seems like a very big term, but it's an industry ambition. And there are multiple, forums out there trying to put form and shape and define what does it mean and how do we get there, right? But there is a simple, but actually at the same time profound, differentiation that we need to understand, which is that ultimately what we need to go is beyond what we understand today as automation to autonomy, right? And it's not one versus the other, it's from one to the other. It's on top of, it's in addition, it's evolving from one to add additional capabilities. Automation, as we know it, as we've been discussing over these days, is highly based on rules, right? Some form of rule, whether it's a workflow, it's a rule, a template is a rule, a closed loop use case, many cases we create rules for that. So these are all forms of, artifacts that we create to address a specific use case, right? And it's perfectly fine, but you can only create those rules, as I said earlier, for event correlation, for the things that are more frequent, right? For the head of the curve, if you represent the use cases in the form of a long tail. But what if you want to start addressing, the remaining of the use cases, that part that you cannot address realistically with rules, right, with artifacts? Then you need to start thinking about autonomy. You need to start thinking on mechanisms, and I know this is very generic, mechanisms that can automatically observe, that can adapt, that can learn, whatever that means. But especially mechanisms that are not dependent on rules. And I'm not saying we have to get rid of rules, because rules are very good for this part of the curve, and we should continue using them. This is not about replacing anything, but this is about getting to a point where we can also address certain use cases without the dependency on the existence of rules, right? And how does this, map into specific, technologies or implementation choices or solutions, right? Well, it depends on the use case, right? Every automation use case can be potentially transformed from the way in which we address it today, based on rules, on whatever type of rule that use case, contains, can be evolved to some way where it also has the ability to automatically address parts or new use cases or new sub-use cases without depending on those rules. And one of those, here are just a few examples, but one of those is event correlation. And that's what I wanted to bring it to this forum. And by the way, Scott, eventually, maybe we need to think about, network autonomy forum, right? From network automation to network autonomy forum. Still enough, right? But so when we think about, let's see if this goes. When we think about event correlation, we have the opportunity to enter into a new way to the event correlation that we could frame it as zero-day event correlation. And why is it zero-day? Because it doesn't depend on rules. It doesn't depend on you creating any type of manual artifact to be able to do, what you have to do today, which is, hey, I need to parse this message, or I need to create a rule to correlate things, right? And because it doesn't depend it, whenever a new event that hasn't been seen before shows up, you would be able still to accomplish, what you need, which is event correlation. So in the era of autonomy, we need to start thinking of new ways to accomplish perhaps the same functionality. And this is one of the things that we're exploring, and is still, in prototype state, but we're exploring what we call semantic event correlation. Mechanisms and architecture, and I will not go into a lot of details because we don't have time anyway, right? But based on mechanisms that can accomplish that semantic connection between different events without depending on humans creating rules, right? And that is what will result into zero-day event correlation. But at the same time, achieve an outcome, a correlation that is of high quality. Because only with high quality, your operational teams can really trust that, hey, this classification of an incident and event, the events that belong to it, really belong to it, right? They are not events that have to do with other things. So I want to show you a quick example of one of the tests that we've been doing with this approach, with this technique, right? Which I think is representative of what might happen in a network. Obviously, this is a small network, it's just a lab environment, where we have a bunch of routers, running OSPF, running BGP, and so on. And then, we're going to have a hardware failure simulated in one of the nodes. As always, this hardware failure will cause events to be generated in that place, but also will cause events generated somewhere else, which are just collateral effects, because ports will go down, BGP sessions will go down, and many systems are going to complain. And of course, you want to be able to tell the NOC engineer, hey, all these events that are happening, they're all together, right? Don't try to troubleshoot them independently, because they all belong to the same incident, right? One fundamental ingredient for this is the existence of a graph. As I was saying earlier, graph-based correlation is fundamental, right? But now one of the key points, as you will see now, is how can we use this graph-based correlation in a way that we are entirely non-dependent, let's say, of the existence of rules to parse, to interpret the events that are coming, right? That's part of the architecture. But the consequence of the correlation and the semantic mapping that we do in the first stage is the creation of a new graph, a new knowledge graph, which is based on the events. And those events that are really connected with each other result into subgraphs that can be extracted, and each of those subgraphs is effectively an incident, right? Because these events in some way, maybe not all together, but maybe by pairs, they have found to be related. Right, and when we did this exercise with different tests on this, lab scenario, many events were happening across different locations of different points of the network. But the algorithm, found this incident, right, incident number like 24, right, and it found all these different events, which were syslog messages. They all belong to the same incident, right? Of course, the first consequence is you went from 22 different events to a single signal, to a single incident that is what the NOC engineer would receive, right? But the key differentiation here, the key interesting attribute is that there was no false positive and no false negative, right? This is what determines the quality of the correlation, whether if you get an incident, all the events that are part of that incident are in the incident, are not outside somewhere else, and vice versa, that you are not putting together events that are unrelated to it. So when you get that, grouping, that clustering of events that is so effective, then you can use something that is very easy to use, very simple to implement, but highly effective, which is, because of course, if you still have these 22 or whatever number of events together in a list like this, or in a dashboard, you still need to look at, what does it mean, or what happened? There's so many different events, you still need to troubleshoot, but then, language models are extremely good at interpreting all that, right? So then you can get this through a language model with the proper definition and get some very curated results of what happened, right? Perhaps also why it happened, what was the elements impacted, involved, et cetera, et cetera. And of course you could say, is that all? Is that all about just pushing this result into an LLM? No, because if you push a bad correlation outcome into an LLM, garbage in, garbage out. You will get trash. You will get something that is useless because the LLM will get confused. So this type of analysis only works if you can get truly high quality correlation, and that's the challenge historically, right? So if somehow we try to visualize in a graph, right, what is the relationship between the correlation quality and the time that the correlation system saves to your operational teams or to your operational engineers? Well, if the correlation quality is low, it's not that it doesn't save time. It will make your team waste time, right? So the saving is negative, because your team will first will need to figure out what is real, what is not, what events are really together, and then once it has figured out, then go and actually troubleshoot the problem. So it would be even better to have no correlation system whatsoever, because the results are actually misleading. As you use systems based on perhaps rules and so on, and depending on the quality of the rules that you maintain, right, and the number of rules and so on, you can start getting some benefits of that correlation, at least for some use cases, right? But how do we get to this right-hand side of the curve where we can start having an exponential growth on the benefit of the correlation? Well, that's where we need new techniques, and we can take advantage of the techniques. One of them, for example, the architecture that I was showing you or that we're exploring. So I think there is an opportunity, in this era of autonomy, to rethink how we implement or how we automate certain processes. In this case, event correlation. We really need to have the aspiration of zero-day event correlation, and also, by the way, zero-day for other things, because in the era of autonomy, we need to start depending less and less on human-created artifacts, and that means, being more zero-day in many use cases, right? High-quality zero-day correlation is fundamental for a success of a network operation team and to be able to manage incidents and faults properly, right? And somehow, in the era of the autonomous network, we need to start embracing this type of techniques that allow us this transition from automation to autonomy, right? So that's pretty much what I wanted to share. I don't know if you guys have questions or comments.
Hello. Here?
We're here. Oh, okay. Yeah.
Thanks very much for the presentation. It was excellent. I was wondering if throughout this journey, did all this knowledge impact the approach that you have in terms of reporting, and not only, let's say, static reporting, but reporting of the long term? So when you analyze the quality of the connections, the quality of your network on the long term, does that kind of approach impact the way that you report stuff on the long term?
Well, I think that could definitely part of it. Is, from what I was showing here has not taken that into account, but I think the long-term history and the feedback of the incident management is extremely useful to manage future incidents, right? As it was, also explaining in the previous presentation about, NetBrain, right? How past events and how those events were dealt with can be useful to decide what to do with the next event. So I think definitely the past history should be also a part of the equation, right? To be able to maybe, automate processes based on the knowledge that has been captured already.
Hi. First row on your right.
Where is okay.
The advantage of rule-based correlation is that it has very low false positives, since you can define very precise rules. How do you plan on handling false positive with semantic correlation, since it's a long tail of very heterogeneous cases? You must have some level of false positives?
Mm-hmm. Yeah. So, the good thing of rules is that they are 100% deterministic, right? And if an event hit a rule or if it didn't. Or if it hit the rule and the rule was wrong, you could potentially troubleshoot it. But of course, where there is no rule, you don't know, right? It's a dark space. In the long tail, you don't want to have rules. You want to have mechanisms that should be able to learn and they make decisions. But as part of this, there is a probability of failure. So the best way to deal with this is similar to what I was telling there with human feedback, right? You will not know there in real time. The algorithm will not know whether the correlation was successful or not, right? But if you can capture human feedback through the process that, hey, this event, actually was here, but it was not included, and so on, you can actually make the cycle, better over time. So that's the only realistic way. These are like potentially like after the thought or after the fact rules, right? That are addressed, that are trying to address maybe lack of knowledge on the model or on the architecture, right? That's the way I think it should be addressed.
Sorry. Hi. Here.
Where is here?
In the end. Yeah. So before I seen several basically
I still
the
don't know. I still don't know where it is.
Oh, at the end here, on the edge.
Okay. Yeah. Okay. Yeah, it's dark over there, so.
Yeah, a little bit. We are in the dark side. So I have a question. Before I seen the graphs, how can you get such good clusters? Which kind of algorithms do you use for having in the semantics that you can have completely isolated without any issues within clusters?
Yeah, I will not go a lot in the detail, right? Because it's still part of what is being in develop. But now we have the opportunity to take to leverage technologies that didn't exist 2 years ago or 3 years ago, that have the possibility to semantically interpret events with high precision, right? Without the need to create rules for that, and that's what drives this, ability to, properly map entities to a graph. And once you have the entities identified in the graph, everything is mostly as we know it, right? It's about correlating on the graph itself, whether it's based on, distance or any other algorithm there. But that's the result of these different stages is what results into that ability to more clearly differentiate between different clusters of events.
So I also get a question about the graph. So one point is to get the events, but the crucial point I think is to get the relational graph, because that gives the meaning to the whole system. So what are the points you collect to get to build this graph? So from which tooling are you getting all this information, or just from the network itself, or kind of configuration, controllers?
It could be from anything, right? I mean, what I was showing is a little bit conceptual, but what mechanisms do you use to build that graph, and how granular or detailed is that graph is an implementation, detail or choice. But definitely the more entities that graph contains and the more precise the relationships, eventually even dependencies, right? You can have maybe relationships, but in some cases you have dependencies mapping. And if you have dependencies, then you have a causal graph that will allow you to potentially do, a more realistic root cause analysis. Otherwise, it might be just a hypothesis, right, from a root cause analysis perspective. But how you discover, it could be based on your controllers, it could be based on parsing configurations. It all depends on the implementation choice. I was not showing any product or any specific implementation, but there could be a lot of ways to do that.
Javier, thank you very, very much.
Thank you.